That is very good. So this is where we stopped the other time, right?
Yes.
And people did the exercise. I want to first, by the way, start by thanking Nalokenge and who? Lineage. Nalokenge and Lineage. For them, they submitted their work. The rest, I don't know what they are doing. Are we students of St. Kizito or we have become villagers? You have become villagers, eh? Students of St. Kizito, they don't behave like that. Students of St. Kizito behave like those of Lineage, those of Nalokenge. Once you give them work, they cooperate and they do the work and they submit. Those people, they have submitted and they have all passed. Can you clap for them? Can you clap for those? Can you clap for Nalokenge and Lineage? Hey, clap for them, clap for them. Lamuno, you are not clapping. Lamuno, you are not clapping. Good. Hey, clap for them, clap for them. Good. So members.
Yes, teacher. Yes, teacher.
I know you are not lazy, but I don't know where this demon is coming from. I don't know where it's coming from. I know you are not lazy. That one, I'm very sure of that. I know you are not lazy, but I don't know what is happening in your life. Some of you. I'm going to pray for these demons so that by the end of this lesson, when we finish the lesson, when I give exercise, everyone is going to submit the work. Is that one clear, members? Is it clear?
Yes.
Huh?
Yes. Yes.
You be there, yes, and I'm afraid to see your work. I will call you direct. You know me very well. You know me very well. I'm going to call you direct.
Everyone can.
Yeah, I'm going to call direct. So, members, before we proceed to what I prepared for you, let's just give some recaps. You know, some have just joined for the first time. What do we mean when we talk of Surds? Who can remind us Surds? What do we say Surd is? We said Surd is a what? Who can remind us? When we talk of Surds, what do we mean?
Shami.
Yes, please.
A surd is an irrational number which cannot be expressed as a recurring decimal.
Which cannot be expressed as recurring decimals or terminating what? Decimals or as an
integer.
An integer. That's the number we refer to as a surd. And those numbers, we said when we talk of recurring decimals, there are some numbers, if we express them, when you put them in your calculator, you cannot convert them to fraction. Okay, when we talk of rational, we say that is the number that can be expressed into fraction. That can be expressed into fraction. And there are some numbers that we discussed, like root of 2. That one you cannot put it into fraction. Root of 5, that one you cannot put as a fraction. Root of 3, the cube root of 4. Those numbers, root of 11, those numbers are irrational. So when we talk of surds, like Beatrice have rightly said, those are numbers which cannot be expressed. Those are irrational numbers which cannot be expressed into recurring decimals, terminating decimals, or an integer. And one of them, we have 2, root of 2, root of 5, root of 3. And one of the example of a rational number is surds. Is it? Surds. And we discussed at length, we discussed different properties, how we can simplify surds. And we said when we are talking about simplification of surds, you think of two numbers that when you multiply them, give you that particular rational number. That number must be rational. 2, in this case, 2 is rational. But when you bring root of 2, it will become irrational. Right together. So the number under the square root, one of the number must have a square root. So like root of 2. Root of 2, you can't simplify it further. You can't simplify that one further because there is no inner number that you multiply to give you 2 apart from 2 and 1. Okay? Are you together, members? So
Yes.
this one is already in simplified form. And when you talk of, you simplify in such a way that the number cannot be expressed into other decimals. I mean, cannot be expressed into other numbers. So just to give a quick reminder, let's look at this example here. Let's look at this exercise. I think what I've highlighted in the side of the note.
Yes.
Yes. So recall, we said if I have root of A times root of B is the same as root of AB. Not so? Why are we saying that? Because they're under the same square root. The number, though the numbers are different, but they have the same power because they have the same square root sign. So that's why we said it's going to be the same as that. Then we also went ahead and said, if I have root of A times root of A, that one will give me root of A squared. But square root, when we talk of a square root means a number is raised to the power half. Square root means a number has been raised to the power a half. So that means that. Cube root means the number has been raised to the power a third. Fourth root means a number has been raised to the power a quarter. So those are the things we discussed the other time. So which means when I multiply square root of A times square root of A will give me A squared. But square root means a number has been raised to the power half. So which means this will give us A squared times to the power half. That's why we say that one will give us A. What do we mean? That is, we can, if I say root of 2 times root of 2, the answer must be, what is root of 2 times root of 2? Members? Members? What is root of 2 times root of 2? What is the answer? Yes?
That's the answer.
The answer is what? What is the answer? Root of 2 times root of 2. Huh? What do we get?
Root of 2.
Root of 2? Huh? The answer is what? Is 2. Okay? The answer is what? 2. Also, if I have root of 5 times root of 5, because when I multiply this one will give me square root of 25. Because root of 5, this one 5 times 5 will give me 25, but under the square root. But what is the square root of 25? The square root of 25 is 5. That's how we get those answers. Also, root of 3 times root of 3, the answer will just be 3. Are you together, members? Are we together on that?
Yes, teacher.
Good. Those are the sum of the principles we are looking at. Those are the sum of the rules we are looking at. Now, let's go to more examples. More examples. Which question should we do? I'm going to do question number 32. I think question 32, this one. The question is saying simplify the following. I'm just doing this for those who have missed the first session because the other lesson. Because what we are going to look at today, we need those concepts before we look at rationalization of a denominator. So I have root of 10 times root of 30 divided by root of 12. So members, what are we going to do in this question? We have root of 10 times root of 12 divided by root of 12. And remember, the question is very simple. The question is very clear. The question is saying simplify. Simplify. How do we simplify Surds, members? How do we simplify Surds? Yes, who can remind us on that? How do we simplify Surds? Yes? Members? Yes, Alexandra. Alexandra, how do we simplify Surds?
By getting numbers that can be able to multiply The number in the square root.
Mhm. And one of the numbers must have a what? A square? A square root. So let's look at this. So this one is going to be the same as root of 10 times root of 30 divided by root of 12. We can write it as root of 10 times root of 30 divided by root of 12. That's another way we can write it. Yes, members? Hello?
Yes, teacher.
Are we together?
Yes.
Yes.
So root of 10. What about root of 10? How can we simplify root of 10? How can we simplify root of 10?
5 times 2.
5 times 2. Someone is saying is that. So we can first leave it as root of 10 because there is no number that we can multiply, and one of them have a square root. So root of 10 times, or what we can do, we put it first like that. Using this principle, using this law here, root of a times root of a is equals to root of ab, right? Which means we can multiply this one to give us root of, see what? 10 times 30, which will give us root of 3 what? 300.
300.
Divide by root of 12.
So
Now from here, think of which number if you multiply them, give you 300, and one of the numbers has a square root. Which number is that? You can come for your side work, get your side work. Which number is that? Members, which number is that? If you multiply, give you 300, and one of the numbers has a square root. Which number is that?
3 times 100.
3 times 100. Good. 3 times what? 100. Members, have you seen that? So we shall have
Yes.
3 times 100, like that. Have you seen that?
yes.
Yes.
What about 12? 12 is the same as root of 4 times root of
3.
3. Now we are multiplying, and we are dividing. So if there are common factors, we can reduce them. You see that root of 12 will root of 3 will cancel with the root of 3. Not so?
Yes.
Then we remain with
Yes.
root of 100 divided by root of 4. But what is root of 100? Root of 100 is what? 10. Divide by what is root of 4? Is what? Is 2. Are there common factors there? By 2, 1. By 2, we get
5.
So the answer for that case is what?
5.
Is 5. Good. Number 2. I'm going to do which question? Which question should we do apart from? We did number 32. Which one should we do again? Select for me one from there. Which number should we do?
31.
31. Good. 31 is root of 10 times 2 root of 2 times root of 5. So here, in this question, what you have to remember, we just have to remember the first general rule. We say root of A times root of B is equals to root of A, B. That's the only thing you have to remember, because here we are multiplying. Okay?
Let me mute you. Nandi, thank you for representing the class at
Excuse me, there's someone playing music in the background. Sandra, please, Sandra. Okay, so we shall have root of A times root of B equals to root of AB. So it implies now root of 10 times 2 root of 2 times root of 5. So this one will give us, now we shall have 2 times square root. Now this 2, this 2 which is here. Now then we multiply all the numbers which are under the square root, which will be 10 times 2 times what? Times 5. Now that one will give us 2
100.
root of, that one will give us what?
100.
100. But what is the square root of 100? The square root of 100 is what?
10.
So which means that we have 2 times 10, which the answer is what?
20.
As simple as
That.
that. Now you do, let's do
Teacher.
you do for me number 32, 25.
Teacher.
Yes?
Teacher.
Yes?
For number 32, which you are from,
Yes.
what if I get the square root of 10 times the square root of 20, add them in one square root, and then expand all of them before multiplying them into one?
It's okay. It's okay. Okay?
Okay.
Yes. It's still, that's what I said. Do number 25. Number 25. I think number 25?
Yes.
Square root of 32 divided by square root of 24. So, like someone have just said, what you can first do, you can first simplify root of 32, then simplify root of 24, then combine them together. So when you combine root of 32, what is the same as what? 32 is the same as?
16 times 2.
16 times 2, which will give us root of 16 times root of 2, right? So what answer do we get? Root of 32 is the same as 4 root of 2, right? Members, are we together on that? Also, root of 24. 24 is the same as? Is the same as 4 times? 4 times?
4 times 6.
4 times 6, which will give us square root of 4 times the square root of 6. So this one will give us 2 root of 6. Now after that, come and put them back here. So root of 32 times root of 24 will give us 32, which we got 4 root of 2 times 24, which we got 2 root of 6. Now what are we going to do from here, members? So we are going to multiply 4 with what?
Oh, with 2.
To give us
8.
8. Then into, then we multiply the number under the square root, which is 2 and what? 2 and 6, which will give us
12.
Do we stop there? But you can see that continue simplifying until the number cannot be simplified further. But you can see that 12 can still be simplified, right?
Yes.
Then you come and say, but root of 12 is the same as root of 4 and what? And 3. So what do we get there? There we get 2 root of what? Root of 3. Come and put it back here. So we shall have 8 times 2 root of what? 3. What do we get? It's not point. This is time per members. That is time. So we shall get 16 root of
3.
That is our final answer. Is that clear?
Yes.
Very good. And that's what we discussed the other time. And I thought it's better when we first do it, and so that those who have just joined to come and so that we move together. Lamunu. Beatrice.
Yes, sir.
Have you seen now? The other time you did not attend that lesson. You did not attend that lesson.
Yes.
Patricia, were you there? What about
No.
Patricia? Yes, now you have understood, right? You have understood,
Yes.
right? Good. Now, members, we shall take a break. After then, we join back, okay?
Yes.
Yes. Don't wait. Once you see that it has gone off, join back. Is it clear?
Yes, teacher.
Very good, very good. That's why I love people. You are very good people.